Hello, good evening. We are back, the SAPI IP Business Talks. Thank you for watching us, joining us. We are live on LinkedIn. That means we are very happy when you write your comments, your perspectives, your questions in the chat. I will try to pick that up and discuss that with our guests today. So we had a long advertisement for this meeting today, because this artificial intelligence thing is big in IP. It has a huge impact, obviously. I mean, my feeling is I'm writing every second day about anything on the impact of AI to the IP world. And there are, of course, different approaches what to do with this potential, with that power of artificial intelligence in the IP world. One aspect we want to discuss today, and that is the question about retrieval, search, and especially analytics. So how can we make meaningful IP design, meaningful inventionship, meaningful understanding of this literature, this very specific literature, patent literature. And I'm very happy that I have two guests here who are working in that field heavily, having developed together a new product. And I'm very curious. So I saw lots of different examples and how powerful that thing is, and to a certain extent magic. And I will ask some questions about that, and I'm happy when you ask also questions. So the two guys are, on the one hand, Daniel Holzner from ABP, a patent firm, service provider, law firm in Austria, and Wolfgang Hildesheim. He is expert on artificial intelligence at IBM Watson. And I guess you know, IBM has a long history on artificial intelligence. Meanwhile, there are others also very prominent using that and promoting it, but still, I would say IBM is still the big blue in that game and has a tremendous background. And so, Wolfgang, explain us what you're doing at IBM Watson, and how did you came into that field?
Yes, thank you, Alex, for the invitation to this very attractive discussion, and the wonderful marketing in LinkedIn on the invitation. Excellent. So my name is Wolfgang Hildesheim. I'm from my education a particle physicist. So from my early days on, I loved magic and complicated subject. I did research on complex data in CERN and Geneva to understand really the base of matter. Later, when I left research, I was a managing director in a family-owned company. So I know family-owned companies and mid-sized companies and how to grow them. And it was a pleasure. And then somehow by chance, I entered IBM 16 years ago and had the opportunity to ramp up and build the IBM's AI business from the beginning. And as you said, Alex, this is all about Watson. So Watson is our logo, like Coca-Cola for sweet drinks. Watson is a logo and a brand for AI and intelligent services. There are multiple services. We will talk about it, not a single one. And we use them to really analyze it in data in an intelligent way. And of course, you mentioned it, Alex, patents are somehow a mystery field, complex text, more than 100 million out there, and nobody can understand how to read this large amount of data. And here I met Daniel and ABP, and we started to work together, and it is a fantastic collaboration, and we will talk about it, and I'm glad to be here and share a lot of details with you.
Thank you, Wolfgang. So we are colleagues. I'm also a physicist by training. So my PhD supervisor told me I should say I was a physicist. In my case, maybe that's very right. Okay, Daniel, Please tell us a little bit. You are in the
Yeah.
middle of the thunderstorm of the IP world and the usage of AI. How did you came into that field, and what you're doing today?
Yeah, thank you very, very much for this invitation. I'm very happy to be here. In my former times, I would say I studied business administration and economics on the University of Applied Science in Upper Austria. So I was very familiar with software projects, project management, software sales, and then I jumped into this IP field at ABP for more than 10 years ago. I have to laugh about because the first days were very strange for me because when you're coming from the business administration and joining all this patent stuff, I was thinking, it was a strange decision from my side to join this area. But after some time and get rid of all the special stuff in the fields of IP, it was pretty cool, and also it was pretty interesting to go deeper insight into how does this field of IP for today, especially the patents area, how does it work? How is the legal background? What are the things? We all know that non-IP guys often tell us that there is a world patent which does not exist at all. So that is pretty interesting, and that was the point. And after this 10 years at ABP Patent Network, you can see in the background from my screen that there is a trademark called Up2IP, which is more or less the IP management software, which is one of my babies at the company, where we started to implement a new generation, an innovative generation of IP management software. And that was in the past also the starting point for dealing with all the AI stuff. That's more or less the point where we started to fishing in this troubled water. AI is a very emerging, not only market, emerging technology. Nearly every week we read about news. There was also this leak about ChatGPT 4.5 Turbo that it will be available in June. So we have a very massive and very fast growing technology, and especially in the fields of patents, we have a very specific language, as Wolfgang mentioned, IBM and especially Wolfgang had a lot to learn about patents and all the language which is used in patents. And on the other hand, we met, I don't know, in summer or in autumn or something like that. And it was a very fruitful meeting where we found out that there are a lot of opportunities in that way. And that's where we are standing now. And we have already implemented the first applications together, and that's very nice. So
okay. So let's jump into the topic. I mean, one aspect is simply the sheer amount of literature which we have to deal when we talk about patents, and especially the number of patent applications at the moment. I mean, they are just growing, and there no end of this development can be seen. And that means for the companies, for all participants of the IP system here, the patent systems in specific, they have to deal anyhow with this huge amount of patent literature out there. And I mean, my understanding of AI tools is that they help, anyhow to handle that. And at the end of the day, we IP experts have to make well-informed decisions, which will have a business impact, and it can be a very serious business impact when we make decisions about IP. I just thinking about freedom to operate or filing decisions. That can be really crucial to the business development. So, first question from my side is, how can IP help here with patent analytics for the experts to make better decisions?
I will start to answer this question, and Wolfgang, I think that you will proceed with some further information, but that's the point. When we met in last year, that was a major point of our discussion. So how can we use all different kinds of artificial intelligence? We are not talking about large language models or generative AI only. We are talking about all the possible solutions we have. And how can we use this technology to provide information in a way that AI is not replacing the experts only? The technologies should support them to get rid of this massive number of documents, and that's the point. And we started with some basic trials on prompting, on NLP, on all the different possibilities and opportunities which we have on the market, and which also IBM and Watson X and Watson offers to us. And at the end of the day, we came to this decision, or to the idea that there is not only a process of using just one technology for, it's more like using different technologies for different aspects. What does it mean? Artificial intelligence or application which is based on artificial intelligence is, at the end of the day, some kind of software development. What does it mean? You have all the technologies also in, for example, pre-processing steps for analyzing data for use, for preparing data for the usage with this artificial intelligence. And there was the point where we met. I don't know. I think it was at the beginning of December, or no, at the beginning of November, where we found out that there is more or less a technology that we can use, for example, large language models, which are available and which are fast growing in the technologies itself. We can use them, but we have to make some sort of a domain specific fine tuning and training for the IP and patents area, because as we already know, we know that ChatGPT is available for everybody who has access to the internet. Also, Copilot is a further development of that. But at the end of the day, these applications which are focusing and dealing with large language models are not specifically trained on this patent language. And that's the point where we realized that we have to set up such a project where we start to train a domain-specific model which is able to understand and to read and to extract and do all the stuff which we want to do. And yeah, Wolfgang, maybe you could.
I understand that you have a model which is trained specifically to this patent language, right?
Not only just one model. We are dealing with different models. Depends on the use case. So when we are talking about a use case, we all know we have, and as I mentioned before, there are so many new technologies and new models which are available. I don't know, or which have become available over the last months. When you think of the company Mistral, which was more or less a spin-off of OpenAI, and also OpenAI and Meta and all the companies. Google also is with Gemini is providing information and models which can be used and can be specifically trained for example, for patent. That's the point. We are using not just only one model, and it's not only using a model. It's more or less a combination of, you can say, software development without artificial intelligence, and some specifically trained models to get rid of this specific language in the first point.
Mm-hmm. Okay. And what was the role from IBM here? Mm-hmm.
Yeah. Yes. So maybe I comment on some of the point, because Daniel really highlighted the revolution here for the IP space. It's an industry-specific a fine-tuned large language model. That is basically the revolution, because it can save a lot of time to read, and then the patent experts can focus on the relevant information. I come back to what you said, Alex. 100 million patents growing, 3 million new patents every year come on top. So nobody is able to read this. Even with classical BI tools, it's hard to analyze them. And even if you are only interested in one domain of a IP field, you have to deal with hundreds, thousands of patents. And here now the new technology comes into play, and the specific challenge is here because text and language is unstructured. So classically, AI was always structured. You can predict things or you can search single word, but this is structured data. Now, IP text, a patent text is unstructured, it's highly complicated, and you can express the same fact in multiple different variations and permutations. And so here you enter in the whole magic of language and the semantic meaning of words and text. And this is not processable by classical digital procedures or classical AI. Here, new AI technologies like generative AI technologies need to come into play. And that's the current mega trend, that pre-trained large language models can provide semantic tools which help to better find and read patent text than the technologies before. This will allow to really save 30, 40, 50% or more of reading time, so that the patent expert is more quicker pointed to the relevant pieces, whether there is IP infringement or open space for innovation, that you can compare text. And so this is prepared in a more digestible way. And here, so the business case is to save reading time. And we all know that IP experts are paid highly per hour. So it's not only a tool for the expert, it's a tool and an approach to save money and be more productive in the field. And the heart is generative AI, and it is always based on a foundation model. Here are all the knowledge representation of these new kind of AIs, and you can adapt them to the language of a certain industry. And what we are doing, we are here with ABP, we develop industry-specific customized foundation models for the patent and IP world. Not a single one, there will be several ones, because you can summarize, you can extract, you can generate text, and for the different capabilities, so you need different customized large language models. And we are in a good way. We started, and now we complete, like for a painter, a painter has multiple colors and multiple pencils. Now we complete our set of tooling with multiple colors, multiple pencils to really paint a wonderful painting, which then will provide a nice overview and picture for the expert and the support for his daily work.
Okay.
Alex, may I ask you one question? When you hear from a IT perspective that patent data is not structured, how do you feel about this?
I mean, to me it sounds strange, because in general, patent data is one of the examples for structured information. But I think what Wolfgang is saying is, when you really have the description and the claims and the question how to compare really on semantic level different explanations, so then the IT guys will call that unstructured information. But
this was a funny point. Sorry for interruption, but this was a funny point when we started to work together. That we also thought that this is structured text, and we learned that this is unstructured text, and we have to deal with that. So that's that was really interesting for us. Yeah.
I would like to dig a little bit deeper. So when I can understand we have this tool set, okay, AI tools. They are based on trained LLMs. The training is about the specific a patent language. So far I can follow. So now when we look to the question, what exactly can we do with it? So can you give us some insights how this tool, which was developed between IBM and RBP together, how this tool is different from other tools, which, as you said, popping up like mushrooms at the moment, for good reason, because obviously there is a need and obviously there is a problem dealing with that huge amount of literature. Maybe this is one of the key examples where this AI technology can really help to improve the situation. Can you give us some details? What it is doing and why it is different?
Mm. When we were evaluating what are the possibilities and opportunities which we can use for our own application, we found out that there is, at the end of the day, pattern language is specific language, and we do not want only to focus on patent attorneys and patent experts. They are they are focused anyway, but we also have to focus on people who are inventing, who are developing things, and they most of the time they speak a very different language. So we started to implement our own approach, which is more or less bottom up. What does it mean? Bottom up means that we try in the first step to transform usual text, which can be written, which could be written by an inventor or by a development resource. We transform this language into pattern language. What does it mean? This means that at the end of the day, we realized, and that was also some procedure or some process which we where we learned over our experience, over our long-term experience, that at the end of the day we are talking more or less about features. A feature is for us in patents, for example, in the claims itself, in the description, also in the drawings, we are talking about features. What has the invention? What are the features of the invention? What is the main feature? And that was our starting point. So we started that we trained this specific foundation model to get rid of these main features. You know that, for example, when you make some sort of a feature list, we realized that when somebody is reading a patent publication, he or she always makes some sort of a feature list in his or her mind. What does it mean when our artificial intelligence application provides this information based on a feature list? A human being does not have as much effort to do to read and understand a patent publication, and that was the starting point where we realized that we focus on this key elements, on this details like features, and that was the approach, or that's our approach, where we are different from other approaches. So we do not search, for example.
Yeah, just that I understand
Yeah.
it. When you say features, does features means claims or parts of claims, or what is a feature?
A feature is more or less what is a characterism for a claim, for an invention. Maybe when you think of a pump, you know that some details of a heat pump or a pump is characterized in different features. So this is more or less how this patent or this invention is described, and it is described in different features, and all the features together is more or less the combination, which is the invention itself. To bring it to a very easy formulated point, Yes, and that's our approach to deal with that, and also in the next application and next steps which we made in the last months from the beginning of this year on, we focused on this approach and also tried to prepare all the information. For example, when we go back to the process. When you have, for example, invention disclosure, where your inventor describes his idea or his or her idea, you should pull this text out and transform it to the, for example, in pattern language, and make, for example, comparison, find out prior art, find out everything. But there is this necessary step to transform, I would say, common language into pattern language, and that's the point. And we compare it more of comparing and finding documents with single keywords and similarities and so on. I hope you could follow.
So you help. I think that's very interesting. So you really help with the communication between inventors or R&D guys who typically have not that way of speaking about features, and you are able to translate that into the language of the patents, which is typically used in that technological field, so that that you really can compare at the end documents which are relevant for the description which the inventor made, which is not using the patent language.
Yes, that's definitely right. So we are more or less trying to build, you could say, virtual claims out of a text. So because in our understanding, and I'm sure that many of the patent experts are in the same or are with me. The claims are the definition of what is the invention about, and so we are setting up and extracting from text more or less claims, and this claims results in features, and there is the point where we can compare more or less the details of a description of an invention with the details of a patent publication or a granted patent, and that's the different approach which we are following.
It could, and okay, and when your starting point can be just a description of a maybe invention, from which is written or explained by somebody who is not trained in that field, then I would assume then it could be anything else. It could be also something from the internet, a product leaflet or whatever. Then you could also use that kind of starting point to compare that with. So you create these virtual claims, and then you can compare it also with patent literature, right?
You're definitely right. That's the point. So we are in the first step we are dealing with this patent literature. But when you go for, or when you think of the future, we are also able to, for example, use a description or a manual of a product to compare it with, for example, patent literature. Yeah, that's definitely right. That's our approach, and that's the technologies. That's the technology which we use for nearly everything. So also for supporting text patent publications, for faster reading, for reducing time, for maybe patent experts, also for inventors. We prepare the information so that they can compare their own idea, or maybe a patent expert another patent application with similar documents. Now we are talking about patents, but in the future this could also be some other literature.
And Wolfgang, how did that happen? So, I mean, creating these virtual claims, how was that cooperation that works?
Well, we should maybe go one step back again to highlight one important aspect of this solution and approach, and this is all about security It's all about privacy. As you guys know much better than myself, how sensible and confidential the information of our IP is. If you want really to plan your IP, do competitive comparison, and then invest billions of money, for instance, in a car company in future inventions, this is highly private, confidential. It's a holy grail, more or less, and you would never put it in a public cloud. And here we come to the point that most of the generative AI solutions today are run out of worldwide public clouds, where the data center is abroad, even not in Europe, or where you don't know the model. The model is huge. It costs a lot. You are not in control. You have hallucination. You have error. So a lot of risk and challenges are coming from these generative AI solutions offered from public clouds. And that's why with ABP, we decided jointly we want here to build a secure, fully private, fully 100% protected environment infrastructure in the data center of ABP. And when the ABP management, Alex, I need to tell this story, showed me the first time the data center, I was really fully impressed. It was really in the mountains, fully protected. You know, in Austria, there are a lot of mountains. So very protected, bomb secure. And then there's a container and it's waterproof and no water can come in. And then we opened the door and and it was 5% oxygen level because it was fire protected. And so we had to wait some minutes before we entered. And then inside in the internet, we posted a nice photo, Daniel and myself. We were standing in front of our Fusion HCI hyperconverged infrastructure, which we delivered to Austria, to the data center of ABP in January, which is a fully and complete generative AI infrastructure to train, to monitor and to run these models out of the fully protected environment. So no access from outside. So clients from ABP can save all the confidential data and do all the analysis in this fully protected environment. And so this is a very important point. If we discuss all these capabilities, you wouldn't do it if this is not somehow the condition, and you need this protected environment. And then on this computer, you have two nodes with GPU, graphical processing units, so very fast computers, which can do this needed parallel computing for generative AI. One node is used with 3 GPU cards, NVIDIA cards, you read a lot in the newspapers, to train the different models. And while the experts from ABP, my colleagues, the experts from IBM, continuously improve and develop new models, on the other node, the produced models can be run and used either in the products of ABP, as Daniel explained, or can be published through a REST API interface through the private cloud of ABP to other clients. And here we somehow build in a family-owned environment a hyperscale model. This is a generative AI ecosystem model, which is set up to really grow in an environment. And that's highly attractive. And to do this, you have to have this environment, but you have to have an agile team as well. This as you highlighted, Alex, this pattern experts who understand the language, so of claims and features and summaries, and really export and all these things, the different formats and how you do it. And on the other side, you have to have the developers, where you then need to model this in an algorithm, and you need to teach it to a large language model. And so longer this journey and this revolution will go on, more intellectual property will be in this customized layer of the large language. A large language model means that you have hundreds of columns, hundreds of rows in multiple dimensions, and it's pre-trained, for instance, on English language. But now to customize this model, you change the 10, 20, 31st layers of this model, and you teach to this customized model the IP language of a certain domain, for instance. And then you have the representation of this semantic understanding in this customized layer. And so better these solutions are becoming, more we can do, better tools we can offer to the IP experts through the different models. And we start with some models to extract, some to summarize, some to generate. So there are typical capabilities, but in 2, 3, 4, 5 years, there will be much more, and we can read then and generate then tables and images and molecule data. We at IBM have a molecular large language model. So all this could now, while we go on, incorporated, and so the supporting tools will become more broader and can help in more activity.
So we are on a journey, and this is a starting point of a journey. And we have this environment which is decoupled from the cloud, so it's a safe environment. And this is also a space which is available for clients from ABP to use it, to train their models. And also we talk about a tool suite, so we have much more than just one tool, and also we see that these tools were also further developed to do other things compared to what they can do today. But when we
Alex, let me maybe add one aspect of one important characteristic of the tooling, that it is open. Open means open source. So it's more or less transparent and understandable by the entire open source community worldwide, more than 6 million developers. And if you use open source libraries to do this, this really creates trustworthiness and confidence while you operate with in a proprietary environment, like for instance, OpenAI. It's not publishing how the model is structured. It's not publishing which data was used to train. It's not publishing what is coming. It's a proprietary environment, and you want clearly avoid dependencies on proprietary solutions. You want to protect in Europe, in Germany, in Austria, our sovereignty, so that we are ourselves in control what we do. And that's what here ABP doing is really world class to start to create this sovereignty.
Okay, got you. Yeah, I understand. Now I understand better where the difference maybe are, but that is a clear characteristic on that solution. So I would like to come to the question of application. So there are obviously numerous of application cases where the tools can be used. But I'm really intrigued by these translations, so that because this is maybe one of the biggest issues when it comes to work with inventors, with R&D guys, so that they have a huge problem. A huge hurdle is the usage of the patent language compared to how they talk about, let's say, use cases, customer journeys, their own technology, whatever it is. And so what would you say, how can this tool support an invention process which is in a company, for example? So what can the tools do here?
Alex, I've brought some slides with me. I transferred the slides while we are talking. Maybe you can show them. So I brought some slides with me where we can see what are the differences in use of this different use cases. So I hope this will work. Yeah, good. So just when we are talking about reduced reading time, so it doesn't matter if the quality of this picture is good, but when we think of claims and texts of patent publications, you can get them as a PDF document, or in that case, out of our solution as extracted text in a software solution. But as you can see on the left side, you have all these different claims. And for one example, we introduced to separate features based on the independent claims. What does it mean? You see that in the background, you see that you have a lot of different text you have to deal with when you want to get informed about the patent publication itself. And on the second screen, you see that this is reduced to this part of text where the features of the different claims is extracted by artificial intelligence. So this was one point where we can support patent experts or any expert who is reading a patent publication to transform for example, one of the most important informations, the features, the independent claims, transform them into features. But what you have mentioned, and what also I have mentioned, is that we want to translate it into patent language. So, for example, it is also just a simple flow, more or less. You can type in text. Therefore, I used a patent description. We also tried it with white papers, summaries, abstracts, invention disclosures from our clients. So you type in text, and as you can see, we transform this into claims where you also get out the different dependent claims. So this is transformation and translation from text into claims, which at the end of the day results in features. This is not perfect at the moment, but when you think of how long would it take when you get a text, you prepare a claim set, you then later on think of all the features which are included in the invention. So this is done within seconds when we're using AI. And at the end,
so Daniel, excuse me, we have just 2-3 minutes left. So is there something which is really important which you would like to show? I think we should focus on that.
Yeah, that's my final slide. I'm sure. So here you can see on the left side, these are extracted features. It doesn't matter what's the content about, but these are extracted features. And the point is that we are able, with this bottom-up approach, to search similar documents in patent literature, for example, this different records. And as you can see, these bars, you have also the possibility to more or less see where is, for example, this feature one, where was the hit in specific documents, where are the different hits. And the point is also to drill down, that you can jump into the details and see where's the reference text, where's the text where the feature was more or less extracted. And that's the point. So we can serve nearly every different question, or answer different questions with this approach. And when you think of the future, you can more or less change the features in that case while the system shows the different similar documents.
To the other slide. So what I understand is that the slide after that. Because what I learned is that, and now next slide, that on the right side we see the document. This is a Chinese application, right? And what the AI is saying is that this green part is the part in the document which shows the similarity of 96% with the original question with the original feature explanation from the R&D people.
Yes, exactly. Definitely right. Yeah, that's the point. So we are comparing on feature level and not on document level. That's the point.
Brilliant.
And that's the difference. And we are sure that this will improve and reduce a lot of time efforts which somebody must must bring to read and understand, and also make strategic decisions on whether preparing an opposition or not, or on the filing of a patent on inventions. That's more or less the summary on all the different topics we talked about.
So thank you very much. The 45 minutes are over. It was very intensive. I'm sure we should meet again and talk again about that. So this bottom-up, top-down approach. I mean, at the moment, we have to learn a lot about the different approaches and the different applications. I think that is really a very serious approach what you did here, and very meaningful from the whole setting. So when you have questions, so I have the feeling that the audience is what a big audience, but we have no questions, nothing. So I had the feeling that they're just listening what's going on here. So when you have questions, don't hesitate, write it in the chat. Our experts will be there and are willing to answer when you have additional questions to that topic. So thank you very much. Thank you, Wolfgang. Thank you, Daniel. Enormous work. I wish you all the success, and I hope we stay together and make that available to the market and collect experiences. And we are planning to work together also with the master program, with our students to give them the opportunity to get their hands on that tool and to work with it. I'm very happy about that. And thank you very much for staying with us. Thank you for today, and see you soon in the next IP Business Talks. And thank you to Daniel and Wolfgang for explaining us what's going on. Bye-bye.
Thank you very much. It was a pleasure. Thank you. Bye-bye.